In this video, we are going to talk about semiconductors. When you hear the word semiconductor, what do you think about? Semiconductor. Semiconductor are basically semiconductors have properties that are in between insulator and conductor. Okay, insulator and conductor. Insulator do not conduct electricity at all because they have a very high resistance to the flow of electricity, and insulator consists of non-metals such as sulfur, iodine. These do not conduct electricity at all, so these are non-metals. On the other hand, this conductor is basically metals. Those are very good at conducting electricity. For example, we have copper, zinc, aluminum. Those are very excellent conductors. Semiconductors are basically metalloids. They don't conduct electricity as well as conductors. However, they do conduct a small amount of electricity. Now, some good examples of naturally occurring semiconductors are silicon and germanium. Okay. Now, germanium conduct electricity better than the silicon, but both of these are semiconductors. They conduct a small amount of electricity. Now, how can we change the conductivity of a semiconductor? How can we increase it? One way is to increase the temperature. Like if you increase the temperature of a semiconductor, the conductivity increases. Let's say silicon. This is true for all the semiconductors. But if we do this for conductors, metals, it's going to be opposite. The conductivity decreases as the temperature increases. So let's say copper. This means that metals conduct electricity better at colder temperatures. Semiconductors conduct electricity better at higher temperatures. Now, other way in which we can increase the conductivity of the semiconductor, like silicon, is to add impurities to it. We can dope it with other atoms. Now, before we go for that, let's briefly review the structure of the silicon crystal. Silicon has 4 valence electrons. Now let's get rid of this one. Okay, silicon has 4 valence electrons. Silicon and the atomic number of a silicon is 14. Every silicon atom has 14 electrons, 4 of which are valence and 10 are core electrons. But the valence electrons are the ones that participate in chemical reactions. So I'm going to put other silicon atoms around it. Like each silicon will be attached with 4 other silicon. Each of them have 4 valence electrons. Okay. Now, in order to form a covalent bond, we have to have two electrons like this. So this is going to form a covalent bond like this. And also the other silicons, they will form another 4 bond with another 4 silicon. So it will go on and on and on, right? So silicon, like, it's similar to diamond. It will keep going on and on and on, right? Now, similar to the structure, however, like, properties are very different. What happens if we dope it with silicon with an element that has 5 valence electron? Let's say like phosphorus. What's going to happen if we do that? Like, let's see. Let's get rid of this one. So silicon, basically, if we throw the bond alone, we will have the structure like this. Silicon will have the structure like this. Okay. Now if we bond this one with phosphorus, like, let's get rid of this silicon and bond it with phosphorus. So if we bond this one with phosphorus, we are going to have silicon here, silicon here, silicon here, and phosphorus has 5 valence electron like this, right? Now each silicon atom uses 4 valence electron to create 4 bonds, phosphorus is going to do the same thing. It's gonna use 4 of its 5 valence electron to create 4 bonds with the neighboring silicon atoms. However, it still has 1 valence electron to fill, and that extra electron is free to move in a conduction band, and so that electron increases the conductivity of the silicon. So you really only need to add a small amount of phosphorus to a large silicon crystal in order to increase the conductivity significantly. Now this is known as N-type semiconductors. The change carriers of this type of semiconductors are electrons, because we have 1 extra electron, so the carriers are electron, and so that one way in which you can increase the conductivity of the silicon is by adding atoms which has 5 valence electron, and you can create N-type semiconductor. Now what about adding an atom that has less than 4 electrons? Let's say aluminium, which has 3 valence electron. Aluminium has 3, and if you add this one with this silicon, let's see what happens. Okay, let's get rid of this picture. Okay, let's put aluminium here. Aluminium has 3 valence electron, and I'm going to put silicon around it. Silicon, and here also silicon. Here you can see this one can create a covalent bond, can create a covalent bond, can create a covalent bond, but here we have a valence electron for silicon, but aluminum doesn't have enough, right? So that's when it's going to create a hole. So we are going to have a hole like this, and the structure will look like this. The silicon, we are going to have a structure that will look like this. So this silicon still has valence electron and aluminum has a hole, and so what we have is add an atom with 3 electrons to pure silicon crystal. If you are going to like from this one, we are going to get a p-type of semiconductor. Now p-type semiconductor conduct electricity better than pure silicon, so that conductivity goes up, but the charge carriers are not electrons as in the case of N-type of semiconductor, but for a p-type of semiconductor the charge carriers are holes. So it's the movement of holes or electrons they consist that is responsible for the conductivity of a p-type semiconductor. Now in case of an N-type of semiconductor where we had phosphorus, and in the charge carriers we had electrons, so the electrons were free to move in N-type of semiconductors. This is N-type, this is P-type, and those are some basic stuff about semiconductors. I will talk more about semiconductors in my next video. I hope this helps. Thanks for watching.